Hey everybody, we're back. Oh my gosh, already? Is it time? Get excited. Okay, well anyway, today I'm not even actually going to talk to you totally about Simpson's diversity index. Simpson, eh? Yes sir, one of your chair moisteners from Sector 7G. Do kids watch The Simpsons? Is that a thing? It's not a thing, is it? Look, go back. It's on Disney Plus. Watch seasons 4 to 10. Season 7. Perfection. Watch. That's the best one. Okay. Steamed hams. No. All right. Anyway, so it's not that Simpsons. It's Simpsons Diversity Index. So we're going to talk about that sort of today. Actually, I'm really going to kind of just tell you how to do this lab. My phone stops blowing up. You know me. Old Miss Popular. That's why I'm here alone on Friday. But yeah, whatever. Anyway, so Simpsons Diversity Index. How about that? Okay, I want to talk to you about the formula. I want to talk to you about the lab that I'm going to give you. So let's just take a look at it. So first, let's look at what the diversity index is. We kind of talked about that. We're kind of looking at, I have a picture here. We're kind of looking at, hey, how many species are there in this given ecosystem, which can kind of give us an estimate of the health of the ecosystem. It can also tell us how likely we are to find a certain species necessarily, or pick two of the same species. It's about diversity. And then it's also about species richness. So how many of that one species do you have? Like if we're in a forest, well, clearly we're very rich in maybe, let's just say, pine trees, like white pine. Okay, if we're in a pine forest. If we're in cropland, well, the species richness of corn is going to be off the charts because we're literally in cropland. We're on a farm. And then diversity is how many different species you see. So you would expect there to be a very high amount of diversity in a rainforest and maybe a low amount in a desert. Okay. Hopefully I didn't screw it up when I made it, and hopefully that's what you're going to see when you calculate it. We'll see what we'll see. How do we find these things? Well, you have to have some of those muddy boots ecologists, kind I like. They have to go out and somehow sample and survey an area, and there's many ways that they do that. They can make a quadrat. I've actually done that before, where you go out into a forest and measure like certain areas and count the number of, for example, trees that you see there. If you have stuff that moves, you might not be able to use a quadrat sampling method and just count them. That's why I work with plants. You know why? They don't run away when you're trying to work with them. But if you're going to sample animals, you can do something like a mark and recapture, where you're actually setting traps, and then you can capture them, put a little sticker on them, put a little tag under their skin, and then later come back and recapture them and kind of get an estimate that way. So there's different ways that ecologists use to sample creatures. So someone had to go out and sample, and then we use those estimates to kind of scale up and figure out how many creatures are there. And that's how we know when people are like, oh, there's 500 tigers left in the wild. That's how we have an idea. Did someone count every single tiger? No, they used sampling methods, and we can talk about those later if you're interested in learning about those. So we're looking at species diversity and richness, and we can use this diversity index to kind of give us an idea of what we might find where and how healthy the ecosystem is. And we do that by using this formula. I know you're like, oh God, there's not just letters, there's Greek letters. Panic! Where's that meme of the guy who says panic? No, we got to change him to calm. Okay, we're going to be calm. Okay, because we can look at each one of these variables, and all you have to do is plug in a number. It's actually very, very simple. And I've included on Google Classroom a video of someone actually walking through step by step of this diversity index better than I could. I'm not a great math person, so I really recommend you watching that video. Just take a minute, see how they do it, and then you'll be like, oh, I can do that. That's easy, especially, hopefully, after I try to explain it to you. So the D, that's diversity index. Okay, we could call it SDI, but that's what we're looking for. Okay, so it's 1 minus Okay, so all of these things, if you look, it's a fraction. All of these numbers are going to be between 0 and 1. It's a decimal. If you don't get a decimal, you did something wrong. And I can walk you through it. Just ask. Okay, so just so you know, every single answer is going to be between 0 and 1. Then we have a Greek letter. Help. It's what is this? It's a sideways M. That's sigma. And sigma means sum. Anytime you see sigma in math, it means you add up all of those. Okay, so we're going to, at the top, be adding a bunch of stuff. So we'll have like some large number up here. Okay, so it's N. N is the total number of organisms in a particular species. So if I gave you a picture, boop, like this, oh my gosh, I'll explain this soon. You'd have to count up all these butterflies. So one of the N's would be one of these butterflies. You count 1, 2, there's probably some hidden here. So like 1, 2, 3, 4, 5, 6, 7, 8. So for one of your species, you can call them A, our N is 8. And then our N minus 1 from there is 7. Okay, so easy, easy, easy. And then N, big N, of course they have to use the same letter. Why not? Whatever, it's okay. N is the total number of organisms of all species. So that's adding up everything. So we're getting like a fractional number. Okay, so you won't be able to get this until the end. You add up all the organisms of all the species. I really recommend either making like a chart in here, like on a piece of paper. You can do it on the all-powerful Google Sheets. And if you use like a little bit of just, what do they call it? Google Foo? I know it sounds lame, but that's what people call it. If you look up on YouTube, you can totally find videos of people showing you how to do it. They'll call it Excel. That's just the program that's like Google Sheets. But they can show you how to just put these numbers in and just type in some formulas. And Google Sheets will add everything up for you and can probably even calculate the SDI for you. If you need me to, I can try to find that on YouTube. Not hard to find. Literally not hard to find. I bet if you just search up calculating Simpson's diversity index Excel or calculating Simpson's diversity index Google Sheets, I bet you could find how to put those things in there. Now, you won't find the exact answers to what I'm doing because I just made this up and I didn't make a video about that. So that's this formula. Like I said, I've included a video on Google Classroom. It's really excellent. If I figure out how to link videos to YouTube, I'll link that particular one in the description as well because they do a really nice job explaining that. So you're just going to find the Simpson's diversity index for a few different ecosystems and compare them and just follow along with there. So the next part, I just wanted to show you about what I did. So if we were in class, I would have had like these little bags with these little creatures and like it would have been laminated and nice and whatever. But I put it on here on Google Slides instead. And each different slide, some of them are almost covered up, is a different ecosystem. So we had rainforest, cropland, lawn is covered up, savanna, forest, and desert. So what you might need to do, if you look, I have some little notes here for you. You might need to move these pictures around. There's not something completely hidden behind anything. I really tried not to do that. But you can make them bigger, you can whatever. Like all these frogs are the same species. All these snakes are the same. These monkeys here are the same. These sloths here aren't the same. I tried to sort of put them together. These parrots are the same. It was hard. I don't know. For whatever reason, I couldn't find a picture of like tons and tons of creatures together. Probably because they don't hang out together like that in big groups. But I tried to give you like some idea of what's going on. Okay. So all you're basically doing, probably one of the hardest parts is sitting there counting all these. Yes, count all the ants. I know that sounds like a pain. For this one, look, I get it. Do your best. Try to count how many different corn plants you see. You can try to use the little stem coming up at the top to kind of count. If you're like, I got 50 and someone else got 43 and someone else got 28, just look at your own. Do the best you can, okay? If it's not perfect, it's not going to matter that much, okay? So don't freak yourself out being like, I have to count every leaf. What if I got it wrong? Don't worry, okay? If you count them, just do the best you can. You can even get the little, like, if you can get a little marker and just go and dot them off like 1, 2, 3. There's probably like 40 some, 50 some that you can count in there. Don't freak out. For the lawn, count every blade of grass. Don't do that. That's sarcasm. Okay, don't do that. You can count the grass as like one thing, and then you can count each one of these little shrubs. You don't have to count all the trees, just this red one here, maybe this other one, but just count this red one, because think of a lawn. You're going to have like a tree there. Maybe you won't have any trees. In the savanna, you can count the grass, I suppose, as one or two. But in the zebra picture, I tried to tell you to count those, because in the savanna it's grassland, but there are some trees. So you can count those trees, 1, 2, 3, 4, 5. Don't worry about the background ones, 6, 7, 8. Okay, we're not looking for complete accuracy here. Okay, we're not trying to be perfect. We get an estimate. Okay, if we were doing something else in the field, yeah, we'd want to be as accurate as possible. But right now, we don't need to freak out. You can try counting these trees here. That's why I put them here. If it's not perfect, don't freak out. I know you guys like really are perfectionists at times, and it's really like an admirable trait that I wish that I had. But you don't need to count every single tree perfectly. If you count them and get 25, and you could talk to your friend and she got 30, it's okay. Don't worry. You don't have to change yours. Just work with what you got. Okay. It doesn't have to be perfect. We're not looking for that level of perfection. This is just this is bunch grass. That's one. Okay. So you don't have to count each blade of grass. That's one. That's the bunch grass grows like that. That's one plant that just grows a bunch of little leaves on it. Okay. So I just wanted to make sure you kind of get an idea of when you're counting. You don't have to go crazy with counting. Try to be accurate, but it's not perfect. Like, I mean, these aphids here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and maybe a baby, 16. It doesn't have to be perfect. Well, what about this one that's here? If you count it, count it. If you don't count it, don't count it. Okay, we're not looking for perfection. I just wanted to make sure you guys understood sort of like what we're looking for. Okay, so I'm just going to end this here. So I kind of explained to you why we look at the diversity index, what the variables are. I'm including on Google Classroom a really useful video for you to help you understand how to calculate the diversity index. They walk you through how they did it. I really recommend that you set it up very similar to them. And yeah, that's all there is. Ask me questions, watch The Simpsons. Have a good day until I see you later. All right. Okay. Enough from me. Bye. Hope that helps you. See you later.